So you've got like a block on a hill, and there's like a rope holding it. Yeah? So what's the first thing you would do?
Yeah, that's what I was thinking the entire time.
Choose what? Choose A. Well, before that, choose what? Choose like when you're doing this.
A system?
Yeah, there you go. So you choose a system.
Oh.
Now this dot is that system.
31792.
What are the forces acting on this system?
There's tension.
Okay, and I'm going to make sure that the tension pulls in the same direction that that rope is actually pulling on the block. Okay, so there's tension. What else, home chicken?
Natural.
You mean normal?
Yeah, normal.
Normal means perpendicular. Do you know what direction it goes?
Yeah, up.
Okay, so up won't work. Up would be like that. That would be wrong, because that's not perpendicular to your surface. So what you need is,
Or is it like that way?
there you go. So in your force diagrams, you got to take extra care that the directions are correct. So that's going to be perpendicular to my surface. So you'll have to do that on your own. You have to make sure that you can draw exactly perpendicular to it. It'll make a difference. What else, home chicken? Well, in this case, I would always ask yourself, could this happen without friction? And what do you think? Could this scenario with this block, like, would this block stay there and not move if there were no friction? Notice it's tied to the ground. So could that happen without friction?
Yeah.
Totally could happen, right? So what I'm going to do is, if it's possible to actually happen without friction, I'm going to write frictionless. So I'm assuming frictionless because I can, because it's still possible. Cool? Like if it was a guy in a parachute, you can't ignore air resistance, for example. If it's a block slowing down while it's sliding across the table, well, it's slowing down because of friction, so you can't ignore friction there. What else is acting?
Gravity? Or like
Which way?
down.
Good. So that's weight. Perfect. So now, what do we want to do with the forces? What would make sense? Instead of having all three forces acting in these separate directions, what can we do mathematically with them?
Put into like the triangle.
And what we're doing there is we're adding them. The thing is, we can't just add the numbers, because then we're missing information about direction. So we're adding vectors. And the rules of vector addition are you have to place the vectors you're adding head to tail. Okay? And in this case, do you know what the vectors need to add to? Yes. So that's based on Newton's first law. If the acceleration is 0, then the forces must add to 0, the force vectors. And so this is what we're doing with that diagram. We're adding the vectors. Another word for this is this idea of equilibrium. There's also this idea of law of inertia. The word inertia you've probably heard before. All this really just means that when the acceleration is 0, the net force has to be 0. Does that make sense? Oh, we also we describe this as a net force being 0. It's not a separate force acting on an object. It's the total force. It's adding all the force vectors. This symbol means that you're adding. It's the sum of, and then this symbol means forces. So you're adding all the forces that are vectors. Okay? So the way we do that is we just place the vectors head to tail. Now, on this diagram, on my force diagram, the directions are correct. The magnitudes are probably not, because I just guessed. On my vector sum diagram, I'm going to change the length so that the forces add to 0. So I'll draw the weight. There's the weight, right? Is that the correct direction? Being down. So I just copied the weight. Now I'll draw tension. Tell me when I should stop this vector. Why'd you stop it there? But notice I have to also add normal. And normal goes at an angle maybe like that. So you actually stop the vector in the perfect spot. So that these three now, normal, and this one's tension, these all add to 0. And do you know which of these angles is a right angle? Yeah, good. So since this is a right angle, you could tell me which vector is the longest. Which one's the longest? So normal force has to be greater than the weight of the object. And normal force also has to be greater than the tension. Now, unless you know what this angle here is, unless you know this angle, you actually can't figure out if weight is bigger than tension or tension's bigger than weight. At a 45-degree angle, this will make a 45-45-90 triangle, and weight and tension will be exactly equal at that angle only. Does that start you off? Is that pretty good? So what I'll do then is I'll put this up on Classroom so you can watch it.